With the female data in list 1 and the data for male life expectancies in list 2, the next thing I want you to do is find the mean and the standard deviation for the male life expectancies and for the female life expectancies. Find those. The nearest tenth is perfectly fine. In order to do that, you should use the one variable statistics command. So, to get to that command, press the stat button. Press the right arrow to highlight calculate, and we want the one variable statistics command, so I'll press enter. So in order to find the mean and standard deviation for female life expectancies, those are in list 1. So I've already got list 1 specified, so I just have to calculate. So the mean is 73.5 and my standard deviation is 9.3. Again, we're not going to calculate things like that by hand. Those are things that we'll let the calculator do the heavy lifting for us. So the mean is 73.5. The standard deviation is 9.3. So you should record those to the nearest tenth. We'll use those in just a second. Now I want you to do the same thing for the male life expectancies. Those are in list 2. So back to the calculator. We're on the home screen here, so I'll press the clear button, stat, calculate, one variable statistics again, but this time our data are in list 2. So I need to change this to list 2, second 2. If you have a calculator where you don't see this menu, if all you see is the one var stats command, then next to it you have to type L2. You have to press second 2. Then you can calculate your one variable statistics as well. So for male life expectancies, here the average is 70.8. And the standard deviation to the nearest tenth, we're going to make that 8.6. So here's what we're working with. So again, what we're looking at with both percentiles and with this new technique called a z-score, we are really looking at position. Where is the position of each of these data points within this distribution? So how far from the mean, so I put that in quotes, that idea of distance from the mean is a measure of spread. It's, in some sense, it's a measure of position. How far from the mean is 80 years as a life expectancy for males? Well, males have a life expectancy of about 71. I rounded it off just for the purposes of discussing it. Again, the standard deviation is about 9. Well, wait a minute. If you take 71 and add 9, what do you get? About 80. So the idea is, how far from the mean is a life expectancy of 80 years for males? It's about 1 standard deviation above the mean. So how many standard deviations you are away from the mean, that is a useful way of describing the position of an observation in a data set. So I rigged this question. I picked the 80 because I knew that if you look at the mean and you look at the standard deviation, 1 standard deviation above the mean is pretty close to 80. Well, if we want to be more specific, let's actually find the deviation. Remember what a deviation is. It is the observation, take away the mean. Okay, well, let's start with that. So for our observation of 80, the mean is 70.8. So 80 minus 70.8, that is 9.2. That's the deviation. So I'm interested in how many standard deviations can I fit into this deviation. I know that this is about 9-ish, and this is about 9-ish also. So I know that into this deviation, I can fit one of these standard deviations. Let's be more specific by just taking the real standard deviation and dividing it in. Let's see, this is the deviation for 80. How many standard deviations fit into this one? So we're going to take the deviation and divide by the standard deviation. So I want to be more specific here, so I'll go to the calculator. I'm going to clear the home screen, and I would strongly encourage you to use parentheses here. The deviation is 80 minus the 70.8. That's the deviation, and I want to see how many standard deviations fit into that. So I'm going to divide it by the 8.6. What this says is, you get just a little more than one 8.6s. Just a little bit more than one of these standard deviations will fit into this deviation for the observation of 80. This 1.07, I'll round it off to 1.07. What this is called is a z-score. This is a z-score. So for this observation of 80, its z-score is 1.07. This literally says that the 80 is 1.07 of these standard deviations above the mean. And I know it's above the mean because the deviation and the z-score are both positive. So let me explain what a z-score is again. This is the formula for a z-score. Let me give you the definition and then we'll come back and interpret this one and do another one. So a z-score for an observation indicates how many standard deviations away the observation is from the mean of the data set. A positive z-score means the observation is above the mean. That's what we saw here, a z-score of positive 1.07. That's a little more than one standard deviation above the mean. 80 is one standard deviation above the 70.8 mean. So a negative z-score then, a negative z-score means the observation is below the mean. So literally the interpretation of this z-score, what this says is 80 years is 1.07 standard deviations above the mean for male life expectancies. So let's take a look at a situation for female life expectancies. So how far from the mean is 55 years for female life expectancies? Well, wait a second. First, why don't you go look at the female data? Look, the mean for females is 73.5. So are we above or below the mean? We're below the mean. We're actually pretty far below the mean. So this z-score, think about it. Will it be positive or will it be negative? Because we're below the mean, it's going to be negative. And we can already approximate it. So look, call this 73.5, just eyeball it at about 74. The standard deviation, keep your life simple, it's close to 10. So wait a second, if you go to 74 and you go 10 below that, you get down to 64. Go another 10 below that, you go to 54. That's pretty close to 55. So our answer here, when we calculate our exact z-score, it should be close to -2. So let's actually be specific then. Here's the z-score. The observation is 55. Let's subtract the mean. I know the mean for the females is 73.5. So that's the deviation I'm interested in. And let's see how many standard deviations fit into that observation. How many 9.3s will fit into this deviation? So let's take a look, because I don't remember the exact answer. So the actual deviation is negative 55 minus 73.5. So let's divide that by 9.3. So that gives us a z-score of -1.99. Again, we knew it was going to be pretty close to -2 just by eyeballing it. So that's the exact value. So to interpret this, what this says is 55 years is 1.99 standard deviations below. It's negative. So it is below the mean for female life expectancies. Again, this is not fancy math, this is not complicated math, but this is math where we use this to tell the story, to tell the position of an observation within a data set. And the truth is, a z-score is such a useful tool. We'll use it for the entire rest of the class. This is a formula that I would commit to memory.